Hello, everybody. This is Gigi from Kauai Community College. Today's lesson is on polygons and tessellations. Today's learning objectives are to investigate the sum of the angles in a polygon, then to use that idea to investigate tessellations. So some definitions before we do some math here. Okay, take a look at that. You have a bunch of points, and those are being connected by line segments. So a closed polygonal path is the collection of all of those segments. We're going to use this idea of a closed polygonal path to define what a polygon is. These points are called vertices, and the segments are called the sides. So an n-sided polygon is a closed polygonal path in the plane with 3 or more vertices, such that the sides intersect only at the endpoints, and no adjacent sides are collinear, meaning they don't belong to the same line. Okay, so you wouldn't have another vertex somewhere right here because that would be collinear. Okay, so that's not going to happen. Okay, so that's what a polygon is. Here are some examples of polygons and non-examples of polygons. So take a look. Now, let's take a look at the angles inside a polygon. So let's pause and wonder a little bit. So where are the angles? We have this one right here, angle 1, angle 2, okay. Then we have that one, angle 3, that one, angle 4, and this other one right here, angle 5, and this very wide angle 6, and then this angle 7. Okay, the question we want to answer is what is the sum of the measure of all of these angles? So pause the video and think about that. Now, actually, before you pause, I want you to remember what we learned from the last video. That is this. The sum of the angles in a triangle, if you take the 3 angles, put them together, it's a straight angle, and a straight angle is 180 degrees. So the sum of 3 angles in a triangle is 180. Use this idea now to think about this polygon here, okay? I'm going to erase this so that it's less messy while you're thinking about this. Okay, so here we go. So if I know a triangle will give me 180 degrees inside, then maybe I'll just cut these into triangles. Okay, how many sides is this polygon? I have 1, 2, 3, 4, 5, 6, 7. This is a 7-sided polygon. And if I just pick a point, say this one right here, I can divide that up into 1 triangle and divide that into 2 triangles, 3 triangles, 4 triangles, and then 5 triangles. And we know each one of these is 180 degrees inside. So the sum of all the angle, that's 180, inside this polygon would be the sum of all of these 5 triangles. And so 5 times 180 is, let's see, if I have 5 times 200, then that would be 1,000. So I'm going to have to take away 5 times 20, which is 100. So 5 times 180 must be 900. How's that number sense for you, huh? Okay, so the question now I want you to take a look at is what happened, can you generalize this and say, what's the sum of all the angles in an n-sided polygon? Okay, so for example, if I just come up to you and say, oh, hey, my polygon has 20 sides. How many degrees is the sum of all the angles inside? And you should be able to just tell me how to calculate that real quick. Okay, so pause and wonder. Okay, now if you take a look here, a 3-sided polygon, that's a triangle. We know that's 180. If you have a 4-sided polygon, you can see here that you can divide it up into 2 triangles. So 2 times 180 is 360, which, you know, most of us know that information. 5-sided polygon, how many triangles do I have there? 3. 6-sided polygon, I have 4 triangles there. 7-sided polygon, guess how many triangles that is? 1, 2, 3, 4, 5. So how many triangles do you think if I had an 8-sided polygon? How many triangles can I subdivide this 8-sided polygon? And yes, you are right, there are 6 of them. Okay, so learning from this pattern, we would say in an n-sided polygon, there will be n minus 2, right? N minus 2, where did I get that from? 8-sided, I have 6 triangles. 7-sided, I have 5 triangles. 6-sided, I have 4 triangles, and so on. So if I have an n-sided polygon, there'll be n minus 2 triangles inside there. And each triangle has a sum of 180 degrees for all the interior angles. So I would say the sum of all the angles in an n-sided polygon is n minus 2 multiplied by 180. So the question I started out earlier was, if I had a 20-sided polygon, then the sum of all the angle would equal to, well, 20-sided polygon is going to have n minus 2, which is 18 triangles, and each one of them is 180 degrees. And I'm sure you can do that calculation. All right, so that's one of the learning objectives for today. Now, let's take a look at this example right here. Okay, so you might have seen this before in high school geometry. So find a measure of angle X. Pause and wonder. Go ahead and ponder this out. Try it. Once you've tried it, here's what we're thinking. This is a 6-sided polygon, so the sum of the interior angles must be 4 times 180, which is 720. So if you add up all the angles, that would be X plus 120, plus this right here is a right angle, and we know right angle is 90. So The sum of all of those needs to equal to 720. Combine like terms. On the left-hand side, we get a very simple linear equation, minus 610 to both sides. X must be 110 degrees. Now here is what I want you to take a look and try this out. What is the sum of all of the exterior angles in an n-sided polygon? So we saw that inside you have n minus 2 triangles times 180. That's the sum of all of the interior angles. Well, what about the exterior angles, like these right here? Okay, so I want you to maybe take a look. If you want to go ahead and try it out, pause the video and try. If you need some help, maybe take a look at these particular examples before you generalize. Okay, and so what we're going to learn next would be to take a look at tessellations. So some definitions before we study the subject. A tessellation is a tile or a pattern consists of repeated use of the same geometric figures to completely cover a plane. No gaps, no overlaps. That's a lot of words, but here's an example of a tessellation. I repeat it in this picture, the shape is being repeatedly used to cover the plane. No gaps, no overlaps. A regular tessellation is one that is made using one regular polygon only. And a regular polygon, I should say regular polygon, is a polygon with all sides that have the same length. For example, here are some regular tessellations. You're using just the same shape over and over again to cover the plane. A semi-regular tessellation is one that is made using two or more regular polygons. And this is where what you normally see when you talk about tessellations. So here are two examples of semi-regular tessellations. Okay, so that's what a tessellation is. And I want you to just take a look and ponder this question. Okay, so I want you to think about regular tessellation. That means just use the same shape over and over again. Can a regular triangle, and we call that an equilateral triangle, can that tessellate? What about a square? Can that tessellate? And so on. So I want you to go ahead. I'm going to end this video. I want you to go ahead and think about this. Maybe try it out, draw some, use some cutouts if you need to, okay? And I will see you next time.